Hey guys, this is Mainak and you're watching Civil Bro. So this is the third lecture on the G+3 building design using Tekla Structural Designer. So in this particular video, I have covered all the particular loading part and also the design, and then how to generate the CAD files and also the report. So whatever progress you are making, you can let me know in the comment section. And if you're watching this video, better you start off with the part 1 if you're watching for the first time. Get yourself the software installed, and then start working along with me. And there are some concepts of dead loads, live loads, and architect loads, how to take these values, and also wind loads, how to take these values as per the IS codes. So you can go to my channel and click on playlist, and in the tabs playlist you will find all the videos in which the detailed explanation is given. Some of the links of the dead load and live load explanation I have given in the description as well. You can check that out to understand the concept of how these values come from. In the ETABS playlist I have made in detail. So continue your learning, and if you have any doubts or any queries, you can just ask below in the comment section. Even if you're making progress, you can ask, you can just leave a comment in the comment section. And also before starting or after watching, if you find this useful, make sure you hit the like button, because it helps me to reach more people. So thanks, and let's continue the lecture.
So we're going to apply the loads here, and first of all let's go to the plinth level here and apply the dead load and the live loads. And for the loading part, videos, what are the basics, you can just check out that video I had made in the ETABS playlist on the basic of the loads. So I'll just apply the loads here, and first of all we'll select the dead load here. Self weight is automatically inserted here, so I'll now insert the wall loads. And full UDL for the 10-inch walls, that is the outer walls, will go with a load of 11 kilonewton per meter, and for the inner walls will go with 5.5. okay, so here we are applying the loads. This is staircase portion, so it will be 11, and this is the outer wall. The outer walls will apply the load. And since this is the portico portion, in here we'll apply this is the parking, so in this will be the 10-inch wall, and here you can apply the 10-inch wall, or here it will be opening actually. And in the remaining portion, let's apply this 10-inch wall load here. In the remaining portion, apply 5.5. You have to make sure that loads do not overlap, that is, you don't place one particular load over the other. So you want to make sure of that. So if you just select the same place 2 times, then it can overlap and it can cause extra load on the beams. So after that, the dead load is applied. So there will be no live load here, because it is a plinth level. There will be PCC, and all the loads will be transferred directly to the compacted soil up to the PCC. So there will be no live load here, and there will be also no floor finish load here, because all the floor finish load will be transferred to the compacted earth below the plinth level. So we're going to go to the structure 3D, and now we're going to see here the dead load. As you can see here, the load has been applied in the plinth level. So the next level we'll apply the loads. Go to structure 1, and here just select the dead load here, and in the dead load go to full UDL, and here go with 11, and all the outer walls will just apply the 11 kilonewton per meter load. And how to calculate this, we can watch the video in the ETABS portion. And then 5.5 for the remaining portions. Here we'll apply, and in the staircase portion you can just go with 11, here, so like this. And now we'll go for a level load. floor finish load, or will apply for all the tiles and all other things of 1 kilonewton per meter square. And then the imposed load for residential building will go for the level load of your 2 kilonewton per meter square as per IS 875 part 2. So this live load has been applied, and then go to structure, and here you can see this is the dead load, all the wall load and also the floor finish load has been applied, and here in the imposed load has been applied like this. So imposed load can, and the dead load can be copied to the next two levels, not the terrace level. So let's copy to the next two levels. Go to model, construction levels, and just the floor from which you are copying is 1, and make the source of 2 as your 1, and also make the source of 3 as 1, and then click on OK. So this has been copied, as you can see here, these loads, and quickly go to construction levels and make them back as unique. So once these are unique, just click on OK and check that all the levels are unique or not. So everything is unique now. So you're going to go to the terrace level, this structure 4, and go to the 2D version, and after that just go and the dead load. First of all, let's apply the load for the staircase portion, and here we're going to go to load, here go to level load, and give a load of 10 kilonewton in the staircase portion, sorry, not the level load, it will be full UDL, and we will give a load of 10 in the staircase portion here for the staircase headroom, and after that we're going to give a load of your 3 for the parapet wall along the periphery of the slab. So this has been applied. So after that, you can see in the 2D 3D this load has been applied. Floor finish load you don't need to apply it here, just the imposed load as the level load of 2 kilonewton per meter square. This has been applied, and go to structure 3D. You can see the dead load here, and this is the imposed load or the live load. Dead load is and live load has been applied. Since the building height is more than, you can go to your home or model, and then you can measure this. So you can see the building height is your 11.25. It's more than 10. So the wind load will act. The building is in Ranchi, so as per our codal provision in Ranchi, the basic wind speed is 39, and the zone is zone 2. So we are going to apply the seismic and the wind loads. For the wind loads, let's just create some wind panels here, and first of all we're going to go to model, and here you have this wall panel option, and select this panel, left click and left click here, left click here and left click here. Two panels have been applied. Left click here and left click here, left click here and left click here. So panels have been applied, and after these panels have been applied, we are ready to put the wind load. First of all, we are going to go to load here, and we are going to apply the seismic load first. Seismic load, seismic wizard, and code spectra, and ignore seismic below the plinth level. Select the plinth level, which is our base. Type 2, import factor is 1 for residential building as per our code. Next, we'll use model response spectrum analysis. Click on next. We're using RC. These are the options here. RC moment resisting frame without any masonry. Infills. We'll select all other buildings here, and after that click on next, and here you can select here moment frame systems, structural system 1. So we'll select moment frame system, and we'll select moment RC building with SMRF here, moment frame system and RC building with SMRF. So in the previous option here, in all other buildings you can select here buildings with RC structure walls, or without any masonry infills. You can select that portion also. It depends on options, but for now let's select this option, first option. It will be on the safer side. So I'll just make a separate video on this thing. For now you can select these options and click on next, and just include all the live loads and dead loads. Click on next and then finish. And then you need to create some operating load combinations. All the limit state loads are selected. Click on next and then finish. And after that, you just need to go to this option of your wizard for wind wizard for this wind load, and click on this wind wizard and consider topography. You're gonna click this worst case data next, and orientation. If this comes across, then you can click 90, or if it doesn't come anything, then you can stick to 0. Basic wind speed of Chhattisgarh, Ranchi is 39 meter per second. And next, and we'll select this open terrain with numerously closely spaced obstruction. Open terrain with scattered obstructions is the zone. Fetch distance by default is 5 meter. Next, click on next and then click on finish. After this is done, you have this option of your, as you can see, wind load cases here, update zones, wind load cases. Just click on this and you can add this load cases if you want, and you can delete and click on auto. So automatically wind load cases will be added, and this is a smart feature of this. And after that, you go to combination here and generate the combinations here. And next, all the limit state methods are selected as per the Indian codes, and if you are going by other codal provisions, you can also do as per that, US, UK, whichever code you are following. Click on next and then finish, and then click on OK. And after doing everything, just go to this option of validate. So if there is anything wrong in your model, there will be a cross, and we need to resolve that. And if you're unable to resolve that, any issues, you can comment. I'll just make sure that I give a response to that. So after that, you'll go to design and then click on design on static. So as you can see, the design has been done. First of all, I'm going to just get rid of all the loading part, and whichever the columns is failing, we can increase the size of those particular columns here. So what I'm going to do is I'm going to just select these columns here which are failing. Okay, all these columns have been selected which are failing, and I'm going to increase the size of this particular column, and I'm going to just do this as 300 into 300, just increasing the size of these columns. Okay, and then right click and then go to design selection, static. Click on escape. Now as you can see, the design has been it's okay, the design. And one thing I have missed out, and just applying the load on the staircase portion. I'll just show it now. Go to load and click on some imposed load, and here just go and apply the slab load of 3 kN per meter square in this and in this portion. Do this in 3D view as well in all the levels. So like this you can do this thing you need to do, and I'm going to go to load and load combinations. I'm going to generate once again because I have changed the things. And I'm going to design it once again. Design all static. So now as you can see here, almost all the columns are passing. Here one column is failing, and you can let's increase its size in one particular direction. So let's give it 300 into 350. Here the orientation, it will be better if the orientation is this side. So we're going to do here this, let be this 300 and let the breadth be 350, and then click on OK. And for this also let's just increase in this this direction. It will be better concealed. Let's give it the size of 300 into 350. Okay, and then select these two, and then select this design selection, just the option of design selection static. So click on escape. So it is being designed, and let's check the reinforcement of this column, and if required we can also increase it if the reinforcement is not coming good. 60-16 I think it's good, and here also it is, I think it will be also 60-16, this is 60-16, so it is good here. And as for the beams, let's see what are the reinforcement coming in the beams. So 12, 16, 12, so beams also is quite good. And we're going to go to the review and go to the ratio, and this will give us an idea of how it is. So anything about which is this 0.7, as you can see, then 0.9 is the maximum one, so this one is your max, close to max. So let's check this design. So it's around 2T16 and 2T16 per span, and 2T20 and 2T16 per span in the second span. So it's like this. So but all the beams are passing here, and the design is, I'll say it is good to go, the design. And after that we're going to apply the foundations here. So let's go to model. Okay, so foundations, and then pad base column, and then just insert the pad bases like this. And then if you want to insert the the soil parameters, you can do it here. The safe bearing capacity, let's give like 150, or let's give 130 kilonewton per meter square. And after that, design pad bases. So there is a warning coming in if you are doing it by Indian code, so you don't have to worry. But if you are designing by European code, the warning of development length doesn't come. So if that warning of development length is not sufficient comes, you don't need to worry. That is, you just need to worry that it is safe or not. So all is safe, no particular footing is failing, so your structure is good to go. And if you want to generate the reports and the design reports and also the drawings, you can also do that. For the drawings, just go to the draw, first of all, for the foundation drawings, go to the bottommost level, that is P1. We'll go to P1, and then here we'll go here foundation layout, and then I'll just save the file in my client location here, and foundation layout, click on save. Click on OK, and the foundation layout will open in AutoCAD automatically if you have the AutoCAD installed. So as you can see, this is the foundation layout. And in stat foundation, I found that sometimes the result is little bit uneconomical, but here Tekla perfectly economical foundations are designed as far as your that is mainly isolated footings are concerned. So sizes are pretty much economical in comparison, so it's okay, the sizes. And here we are having this, and after that foundation has been designed, and after the foundation has been designed, the next thing which you can do is you can take out the drawing for the beams. So if you don't want to take out the drawing of the beam arrangement and column arrangement, you can also do that. So let's do the column layout first. So I'll just do general arrangement here, and I'm going to select the location, and I'm going to just see here column layout. I would like this column layout TSD, Tekla Structural Designer. and this will give me the column layout here. Let us say this will give me the name of the columns. As you can see, this is the name of the columns here: CRC2 D1, CRC2 D3, D3, everything. And the column details I can find out easily. We have this column schedule. Just click on everything and click on OK, and then just have your designed location. This is the column schedule. Click on OK. So for all the CRC D1, CRC D2, CRC D3, you will now get the schedule. Quite cool, right? So you're finding this column schedule. Suppose for one CRC D1, you can see there is A is 16 mm, B is 12 mm. So you have this 4 bars of 16 mm and 4 bars of 12 mm. And 300 and 300 columns also, you have this 1 2 3 4 5 6 7 8 bars of 16 mm. So like this the design you are having in all these columns. So very much good representation you are finding here for all these particular columns. Also they are giving you the total quantity of steel which has been used in the columns. So it's pretty much in detail. Similarly for the beam, if you want to find the beam details, just let's do for the plain beams. If you click on the general element, you will get the let's go beam plain beam layout, PB for plain beam, and click on layout. So it will be plain beam layout, and this is the plain beam layout. Open in AutoCAD. As you can see, this is the plain beam layout, and after this layout, that is the plain beam layout, you will find the other thing, that is the plain beam details. So here we will just go beam schedule. So we'll just use our location and PB here. We'll write here schedule. So here just click on OK, and here we'll have the schedule here. As you can see, the bottom rebars and as well as the top rebars. So you'll have this detail like in the CRB1, and if you want to find CRB1, you're going to find from here this, as you can see, CRB12, CRB D1. So everything you can find here, and the detail you will find here in this. So it is pretty much in detail all the output here. So we have covered almost everything. And another thing is report remaining. If you want to submit your report, just mainly if you want to first of all see the material takeoff, you can see the material listing, a show report, and just the last page you will find, I'll show you in very quickly. You will find the total reinforcement which has been used, and also the total quantity of concrete which has been used. So it's very much helpful when you have all the details of the materials. And this feature is actually present in both ETABS and STEP, the material takeoff. And after that, the material reports, like you can submit to some agency for proof that you've designed the structure safely. So here you have the building design, and then click on show report, and this will be the full design report summary which you can submit to any government agency if you are an approved planner. So it is very helpful there. And so after that, after it comes, you can also this option will be enabled. You can also take out the printout in PDF and also in Excel. So you can see all the details you will find here. So this pretty much sums up today's video. And if you are progressing in this video, let me know in the comment section. And wherever you are, stay safe, stay happy, enjoy life, and keep learning. Bye bye.